Good morning, guys. Um, this is Brilliant Tech Tutorial. My name is Celestine. On today's video, I'll teach you guys on how to solve partial differentiation involving stationary values of functions. Now, with this question, I have question one. We have that find the stationary point of the function z equals to y squared plus xy plus 2x plus 3y plus 6 and determine its nature. Okay, now we have to find the stationary point of this function and determine its nature. Now, solution to solve this, we have to find what the z over ds and the, and also we have to find the z over dy. So therefore, for us to find the z over dx is, now we have that dz over dx means under z differentiate what x. So differentiate x here, it remains y. Differentiate x here, it remains only 2. That becomes y plus 2. Okay. Now also know that dz over the s mod is equal to 0. Now therefore y plus 2 is equal to 0. I'll call this equation 1. Equation 1. Okay. Now also, after finding dz over ds, I have to find dz over dy. So dz over dy is equal to, under z differentiate what? Differentiate y. So differentiate y here is what? Is 2y. Okay. Now differentiate y here is plus x. Differentiate y here is what? Is 3. Okay. So is 3. So therefore the z over the dy is equal to 0. Therefore 2y plus x plus 3 is equal to 0. So therefore 2y plus x crossover becomes 3 crossover becomes minus 3. So I call this equation 1, 2. Now let's solve equation 1 and 2. Okay, simultaneously. So now I'll say that from equation 1, you know that equation 1 is I have that y is equal to what? 2 crossover becomes minus 2. So if y is equal to minus 2, now say that put y equals minus 2 in equation 1, 2. This is equation 2. So mean that any place I see y here, I put this word, it becomes minus 2. So therefore that becomes 2 bracket y minus 2 plus x is equal to minus 3, right? So which is what? 2 times minus 2 is minus 4 plus x equals minus 3. Okay, so therefore now collect like terms. I have that x is equal to minus 3. Minus 4 crossover becomes plus 4. Okay, so therefore x is equal to what? Minus 3 plus 4 give me what? 1. So therefore x is equal to 1 and y is equal to what? Minus 2. Okay, so what next? Testing. Now therefore testing their nature at x to be 1 and y to be what? Minus 2. Okay, now and for you, if you check in this question, we have to find its nature, right? So I want to find the nature of this. Now at the value, I have to find the nature of this stationary point at the value of what? X to be 1 and y to be minus 2. So therefore, for you to find the testing nature, you always use this is the formula for it. Okay, which is, we say d square z over the x square bracket d square z over the y square minus d square z over the x dy all square. Okay, so therefore that is, so therefore, since the z over the x is y plus 2, now and therefore what will be the square z over the x square? So the square z over the x square means, now in your differentiation of the z over the x, okay, differentiate it again, you have to differentiate 2 times. So therefore in this, now you know that this is the value for z now. Okay, that should be y plus 2. Okay, so therefore we have to differentiate it again. Now you know that this thing should be under z differentiate s, right? You check here, there's no s here, so everything here becomes what? 0. Now also we have to, also since the z over the y is equal to 2y plus x plus 3, right? Okay, now we have to find what? The square z over the y square. So the square z over the y square is what? Let z equal to 2y plus x plus 3. Okay, now you know that we have to differentiate this 2 times. So now since from our initial, from our initial, we got the z over the y to be equal to 2y plus x plus 3, right? So therefore let let's find the square z over the y square. So the square z over the y square means that I have to differentiate this one. I have to differentiate this again. That is making it 2 times. I have to differentiate this again. So therefore, and this simply means that differentiate in respect to what? Y. So differentiate 2y here is what? Is 2. So means that everything here is 2. So therefore, I have to put the answers in the equation. This testing formula equation. So mean that where this square zero, where this was equal to 0, right? I become 0 times this was equal to what? We got to what? 2, right? Now what again? Minus. So therefore, what is minus this? So what is my d square zero over the x dy? So now the what will be the differentiation of the square zero over the x dy? So this thing here simply means that remove x, differentiate only what? Only y. Remove x, differentiate only what? Only y. So therefore equation, this equation simply means that remove what x, differentiate y. It means that you have to check from your from initial equation. For initial equation, this is z equal to this, right? Now check, if you check this, the s and the y, they are together, right? Now check in this equation, in from the initial equation, where s and y are together is here. That's xy. So mean that, as we say that you remove x, differentiate y. So remove x, this x out, differentiate y is what? Is 1. So the answer is what? Is 1. So mean that everything here is what? That becomes minus what? 1. So which is equal to 0 times 2 is 0. 0 minus 1 is same as minus 1. So therefore we say that a stationary point of 1 and minus 2, it is saddle point because it is less than 1, 0. It's saddle point because this thing here, this our testing equation here result to be equal to less than 1, 0, which was our minus 1. Okay, now know that if your testing nature is greater than 0, it is either maximum or what? Minimum. Okay, and also know that if your testing nature is less than 0, it is in a saddle point. And also know that if your testing nature, if your testing nature equation is equal to 0, know that the the this thing the equations the equations still require more information. Okay, now know, if the testing nature is equal to 0, just simply know that the equation still requires more information. Okay, so this is the answer. Very simple. Please guys, if you find this video interesting and helpful, don't forget to like, subscribe, comment and share. Thank you.